Hi guys, how are you? I hope you are fine. I'm also fine. We thank God for this opportunity to be together so that we can learn. I also am learning like you. And so guys, today's lesson is a new one because we are going to start a new topic which is called differentiation. So guys, welcome as we start together. So guys, we start together where we have this. We call them general formula of derivative. These are the general formulas given, and I would like to demonstrate how we come about them. So guys, let's see how we can come to get this formula. We call it general formula of derivative. So here we have a line, which is a curve. All of us know that if you have a straight line graph like that, this one we have a constant derivative which is given by y equals to mx plus c, where our m is the gradient. But now we have a curve. So how do we come about to finding the derivative of that curve? Let's say we have a point here. We call this one point x, which is xy, whereby here we have x and here we have y. But now y, we write it as a function of x, which is fx, like that. Then we can have a small change here. For example, we have a small change, and this small change, let's call it h, like that. So then it means on this other side of y, we shall still have a small change, which is, we call this one fx plus h. And so if we want to find now the derivative of the line at that very point, we know that the derivative, according to the straight line graph, we are supposed to have change in y all over change in x. So we utilize the same principle to this. Now we talk of the change in the x. First of all, the change in y. The change in y will be fx plus h minus fx. That is the change in y. And then we have, here we have h. So the derivative itself is defined as f prime x limit as h tends to 0. Then here we have equals f x plus h minus fx all over h. So this is the definition of derivative. At the same time, we can also have fx prime x, the derivative of x being equal to limit as h tends to 0. Then we write fx plus h minus fx minus h all over h. And this one comes about if you were to consider this other point on this other side, whereby now we say that we move this side the same as h, such that our point is at x, but now we are moving a small change of h in the negative direction, so to say, or to the left direction. So this other one will be fx minus h. So the change is now going to be fx plus h minus fx minus h, which is this one, divided by now 2h. And this is how we come about to get this. So this is our formula for, it's a general formula of derivative. This is how we get it. And now, guys, let's do an example here and see what we will get. We shall be using this formula as we continue. So this is an example. Let's do and see how we go about it. So we are told if fx is equals to x cubed, find f prime x, that is the derivative of x from first principle. So our fx is x cubed. So we write f, now this one is now 3x cubed. So let me write it well here. F prime x cubed. So that's what we want to get. So this one is equal to limit as h tends to 0, f, now we write our x plus now a small change which is h, then we can write 3 there, minus fx cubed like that, divided by h like that. We continue. So f prime x cubed, this one will be equal to limit as h tends to 0. We use now the binomial theorem to establish x plus h cubed. Of course, we all remember the binomial theorem. We can use the Pascal triangle, which is now supposed to be like this. This is the Pascal triangle. So we are using this. So let's continue. So fx plus h cubed is supposed to give us, this is x cubed, that is, we write 1 there, then plus 3 x squared h plus 3 x raised to 1 h squared plus h cubed. That one minus x cubed all over that. This one is now going to be h. We work out that. So f prime x cubed will give us, this is limit h tends to 0. This is going to be, we remove this bracket, we will get x cubed minus x cubed, that is 0. So we will remain with 3x squared h plus 3x h squared plus h cubed. Divide that by h like that. So now we can now cancel all the h's here. We cancel that h, we cancel this one, then we also cancel one of them, so we remain with 1, and here we remain with 2. So finally, f prime x cubed, that is derivative of x cubed, will be equal to limit h tends to 0. This one now you're going to have 3x squared plus 3x h squared, that is h raised to 1 plus h raised to 2. Now, because we are talking of limit whereby h tends to 0, so these h are going to be very small figures. And you know that if you multiply a very small figure, for example, let's say h equals to 0.0001. You multiply it with a large figure, maybe let's say times 40, like that. This one you will get, you can write there 40 and then 1, 2, 3, 4. That is 1, 2, 3, 4, like that. So you find that this one is small and therefore it is neglected. So if you have a large figure here, this which is 3x, you multiply by a small figure, you will get small figure. So this one, small, as h tends to 0, this one is small. This one is also going to be small. And so guys, we'll be left with f prime x cubed equals to limit as h tends to 0, 3x squared. So this is our value that we are looking for, and as you can see, it is there. It is there. That is our answer. And so we do that problem as shown, or you can even follow this route. So that is how we do it. So guys, we look at another example here. Here is our example, and let's see how we can do this example here. We have differentiate fx equals to x squared from first principle. We also have fx equals to 1 over x squared. So let me do this one for you and then you can do this one. So let's see how you go about that. So we use the same formula as we have used before. So the formula is here. The one we had was this one. You can actually put it there, but we are supposed to recognize to be able to remember it offhand. So this is very important, we remember it. So let me put it aside and we continue. So here we have a question whereby you are told to differentiate fx equals to 1 over x squared from first principles. So how do we go about it? We come and write fx is 1 over x squared, like that. This one is equals to limit as h tends to 0. Then we can write f, that is f1 over x plus h squared minus f1 over x squared, like that. Then we divide this one by h. So we can write it like this. This is equals to limit as h tends to 0. Then I can bring out this h here, 1 over h, and then I write it like this. we'll get something like this. 1 over x plus h squared minus 1 over x squared, like that. So we continue with that. We find the LCM for that. The LCM for that will be equal to, draw a line there, then we can put here x plus h squared and then x squared there, like that. So this one divided by that, you get here x squared minus this divided by that, you get x plus h squared, like that. This one is being divided by h. So we continue. Note that the limit is still there. Limit as h tends to 0. So now from there, this one is 1 over h, like that. And so we continue. This one will be limit as h tends to 0, 1 over h, you'll have x squared there, minus, you can use the binomial theorem for that, you'll have x squared, that is plus 2xh plus h squared. This one will be over x, again x squared. Okay, you can leave it like that for a moment. Let's say it's x h, like that. This is plus and then squared. Here we have x squared again. So now we come and remove the bracket here. So we'll have limit h tends to 0, 1 over h, x squared minus x squared minus 2xh minus h squared all over x plus h squared x squared, like that. So we'll say limit h tends to 0. This one will cancel, so we'll be left with minus 2xh minus h squared all over x plus h squared x squared. Then we have here 1 over h. The h will cancel here, will cancel that, and will cancel that and 1 of the h. And so this one will give us limit as h tends to 0. This one will be now become small. That one will be small. And then we are left with this. Then it will be finally limit h tends to 0. We'll have negative 2x all over, we have x plus h squared, and then we have x squared. With this one, we are saying that h will tend to 0. If you have a very small number, you add a big number. For example, you have 100 plus 0.001. This one now becomes negligible. And so we will have finally As we finish, this one will be equals to limit h tends to 0 minus 2x all over, this one will now be x squared multiplied by x squared, which is x raised to 4. Now we can cancel one of the x and one of the x here. So this one will now be minus 2 all over x raised to 3. So guys, this is where now we get 2. This is our solution. And so guys, thank you for listening to me. We will continue with derivative or differentiation from first principle. Guys, bye bye.